So here we have an example, and we just reviewed everything about graphing from factored form. Everyone kind of has their own method. I have a lot of detail in mind, but I do think it's very, very helpful in the long run. Now, the phrase that we use, stinky yetis enjoy ballet. So stinky yetis enjoy ballet. Standard form. Now, this is not in standard form. However, you could pretend it's in standard form and picture it in standard form in your head. You could probably do a lot more in your head than you give yourself credit for. Standard form would mean that this was fully expanded. You might think of the word foil, first, outer, inner, and last. You don't need to actually use foil. But can anybody tell me if this were in standard form, if you could do that in your head? From there, the first thing we would figure out is your Y-intercept. Can anyone tell me what the Y-intercept would be for this quadratic? What would the Y-intercept be for this quadratic? And then also think back. We said the Y-intercept, I underlined it in orange here. It was that number at the end. Before we even do that, does anybody remember what gets plugged in for what in an equation when you're finding a Y-intercept? You plug something in for a letter. Adriana, what do you remember about Y-intercepts? Exactly, you plug in 0 for X. Good. So if we plug in 0 for X, that's another way you could do it. So you don't have to picture it in standard form if you don't want to. So what would be the Y-intercept? How about go ahead, Paige, you want to do it?
You would plug in 0 for X, and then you would multiply 7 times 1 to give you 7.
Good. And we want to watch out for those positives and negatives, make sure we know those rules really well. Or you could think of it as even, because what she just did was perfectly fine. But isn't that the same as what last times last would be in FOIL, right? FOIL, that means last times last. And that would be 7 times 1. And that's what Paige ended up doing. So it all really comes full circle. Like everything is very, very consistent. So stinky would be if it were in standard form. We're faking it because it's not in standard form. Yetis is the Y-intercept. EB is end behavior. Now, last is our Y-intercept. But first times first is really going to give us the information we need for our end behavior. What would be my leading term if this was in standard form? What would be my leading term? Maybe Sol, Tahani, Sean, Natalie, Melvin. What would be my leading term if this was in standard form? The first term of everything, if it was all multiplied out. Everything was all multiplied out. Go ahead, Justin.
First term would be x squared.
Good, it would be x squared. And if x squared, or positive 1, x to the even number 2 power, what's my end behavior for a positive x squared going to be? What is the end behavior of a positive x squared going to be, Liana? Good. It's going to be up on the left and up on the right. Up and up. All right, good. So we're moving along. Stinky, yetis, enjoy, ballet, fuzzy, zombies, play, mind, games. Factored form, check. That's how it was given to us. Zeros. How do I get the zeros if I have something in factored form? I know you can do it. Don't be scared. Don't think I'm probably wrong, or don't say this is a guess, but I know you guys love to say that. What do I do to get the zeros from this equation, which is already in factored form? The zeros. Dylan, Ella, Hashara, Isa. What do we do? What do we do? Right? Go ahead, Liana. What do we do?
Set the x is 0 equal to the numbers. Say that with x plus 7, you would set x equal to
Careful. I know you realize you're saying the wrong thing, right? Yeah, because here is where you set x equal to 0, right? Here, what you're doing for the zeros is you're really, ready? Hold on to your butts. You're really setting y equal to 0. And then that means you set each factor equal to 0. And that's using something called the zero product property. So I know as it was coming out of your mouth, I could even see like the look in your eyes. You were like, wait, hold on. That's not what I mean. Rewind, double back, try again. And then it kept coming out wrong, right? Like you're like, that's not what I'm saying. That's not what I'm saying. I'm not saying that. I'm saying, another thing. But I got it. I got you. So you're really, how here, the y-intercept, you said x equal to 0. The x-intercepts, which are your zeros we said are the x-intercepts. We're going to set y equal to 0. So technically like this. And on this side, we still have these factors. Okay. And then we're going to set that equal to 0 on its own. And we're going to set, it doesn't matter which side we write it on. It's a little weird sometimes when it's on the left, I guess. We're going to set both of them equal to 0. And then we solve for x. Solve for x. And we get x equals -7 and x equals -1. Now I'm going to write my zeros or my x-intercepts two different ways. I'm going to write it first as ordered pairs, which I'm a big fan of because I think it's important we get good at that. That would be -7, 0, and that would be -1, 0. I'm also going to write it in something called set notation. Make sure you jot this down. Set notation is where we use these curly brackets. And the way you draw a curly bracket is you really draw like a dragged out S and then a dragged out skinny S, a backwards S. So it's going to look like this for S for set and then backwards. So think set, S for set, and then no. And then a backwards S, like notation. Okay, so then here we have a backwards S and then a regular S. And what you do is we try to list them in order from least to greatest, and we just separate them by a comma. So -7, comma, -1. So you might see that notation from time to time. So if it's a curly bracket, make sure you pay attention because sometimes it's hard to tell when it's like a font. Maybe it's bold, maybe it's like kind of small. It might at first glance look like a parenthesis. This is listing individual x-intercepts. This is showing us ordered pairs. Okay, so I'm going to kind of show you that both ways right there. So those are your zeros. Where is that? Z. Okay, plot, multiplicity, and graph. So we're tying it up. We got 2 minutes left. We're going to plot those. And we're going to look at the multiplicity. So we said the multiplicity was 1 on each of these. We said it was 1. And then we said that that would be linear. We said our end behavior is up. We got a lot of details. And then we're going to graph. So I'm going to flip over to the next page and we're going to graph everything over there. Okay. So you can rewind or hit pause if you need to. Flip up actually 2 pages because I forgot about this. What was my y-intercept? Can anybody remind me? I think I remember. Okay, good. Thank you. 0, 7. Thank you. 1, 2, 3, 4, 5, 6, 7. Now, if you have graph paper, very helpful right now. X-intercepts were, I think I just said -1, 2, 3, 4, 5, 6, -7. -7, -1. And behavior is up, and it is linear behavior at each 0. So it's going to cut pretty straight through, pretty straight through, and then we kind of turn around and go back up. So it's going to look something like this. Now, if you know those are your x-intercepts, -7 and -1, if you know those are your x-intercepts, could you figure out where your axis of symmetry is? Could you figure that out?
Yeah.
So how do you do that? Do you think you have a method at least? This last thing we're doing, what would the method be to find that axis of symmetry? Or could you at least tell me what it is? Maybe you could do it in your head and you can't explain it.
It's the middle of the it's the middle of the 2 points in the parabola on the x-axis.
You're right. So midpoint, midpoint. What do you do? Add them together. Add them together and divide by. Yeah. So that's our little rhyme of the day. For homework, you guys are going to redo that do now, that warm up. You should be much better now. Okay. And if you still have trouble, please come to office hour today or tomorrow. And that's all I need you to do is get a good grade on that do now. It was 12 points. So now it was a do once for now. That's what I call it today. And now you were able to probably remember some. Now that we did this whole period reviewing a bunch of stuff, you should be able to connect the dots, literally and figuratively. And you should be able to do that do now much better now. So here I'm just going to show -7 plus -1 is -8. Divide that by 2, we get -4. So the axis of symmetry is at -4. So that's where that middle would be. And then I could actually even get another point right here, a mirror point, if I wanted to. Okay, but that's all for today. So just jot that all down. I will upload this video to YouTube a little later, and I have to update that playlist for you guys. And also what you could do is use that pattern that we went over last time. It could really help you out a lot. And I did also make another video. If you don't have a good camera and you want to upload pictures of your work, I taught in a video how you could graph on the computer by hand, but on the computer using a Google Doc, and you could submit your homework that way if you wanted. So maybe that's more appealing to you. And if you're interested in that, you could watch that video. I'll try to tag it at the end of this video. And next class, we're going to basically work on a classwork assignment. Think of it as like a open notes quiz. And we're going to work with all 3 forms, going back and forth between them. And hopefully we can get really good at this, okay? So have a really good day. If you understood it, thumbs up. Don't understand? Thumbs down. And I will go from there, okay? Have a good day, everybody.